Okay. In this video, we are going to discuss about the compressibility and bulk modulus. Compressibility is the reciprocal of bulk modulus of elasticity, which is defined as the ratio of compressive stress to volumetric strain. Consider the cylinder fitted with the piston shown in figure. Here let V is equal to volume of gas enclosed the cylinder. P is the pressure of the gas when the volume is V. Let pressure is increased P to Tp. The volume is decreased. So increase in pressure is dP. The decrease in volume is dV. The volumetric strain is minus dV by dP. The minus sign indicates that volume decreases with increase in pressure. So bulk modulus K is equal to increase in pressure, the ratio between the increase in pressure to volumetric strain. The compressibility is the reciprocal of bulk modulus. Here, to determine in this problem, we know that the bulk modulus and compressibility. They determine the bulk modulus of elasticity of the liquid if the pressure of the liquid is increased from 7 Newton per centimeter square to 130 Newton per centimeter square. The volume of this decreased by 0.15%. In that condition, we will go to this determine the bulk modulus of elasticity. Bulk modulus of elasticity. Okay. Next one, the surface tension. When the liquid and gas or two immersible liquids are in contact, an unbalanced force is developed at the interface, stretched over the entire fluid. The intensity of molecular attraction per unit length along the any line is called surface tension. The surface tension is defined as tensile force acting on the surface of the liquid in contact with gas or to immersible liquid between the two immersible liquids, such as the surface behaves like a membrane under the tension. That is called surface tension. Okay, the tensile force may be considered acting on the plane along line of the surfaces. Next one, the phenomena of surface tension arises due to the two kinds of intermolecular forces. One is coercive force, another one is aggressive force. The coercive force means force of attraction between the molecules of the liquid by the virtue of which they bounded to each other to remain one assemblage of the particle is known as force of coercive. This property enables liquid to resist a tensile stress. And aggressive force attraction of between the unlike molecules. Okay. Next one, the surface tension denoted by sigma. Its unit is Newton per meter. The important example of the phenomena of surface tension is raindrops, capillary rise or capillary chipping, and collection of dust particles on water surface. That is pressure, intensity of water surface, and soap bubbles and liquid jet. Let P is the here water droplet pressure and surface tension, and draw the free body diagram also. P is equal to pressure inside the droplet of the pressure above the outside pressure, and diameter of the droplet and surface tension of the liquid. From that, under equilibrium condition, we have the point pressure is equal to 4 sigma by D for the bubbles. Next one, surface tension of liquid. We solve this problem in the surface tension of the soap bubble is 40 mm, where the inside the pressure is 2.5 Newton per meter square above the atmospheric pressure. From that, we can find the surface tension. Okay, here we find the diameter of the droplet of water. Surface tension of the water is given, that is 0.725 Newton per meter square. The pressure inlet the droplet of the water is to be given greater than the outside pressure. Based on that, we can calculate the droplet of the water, that is P is equal to 4 sigma by D. The pressure value is given, sigma value is given. From that, we can calculate the diameter of the droplet. Next one, capillary. Capillary is the phenomena by which liquid rise into a thin glass above or below its general level. The rise of the liquid surface is known as capillary rise. The fall of the liquid surface is known as capillary depression. It is expressed in terms of cm or mm of the liquid. It depends upon the specific weight of the liquid, diameter of the tube, surface tension of the liquid. The expression for capillary rise From that capillary rise means it is given the aggressive force is greater than the cohesion, liquid width of the surface, but capillary diffraction, aggressive force is less than the coercive force, stays away from the surface. From that we can calculate the H equal to capillary rise, that is capillary rise H equal to 4 sigma cos theta divided by rho g into d. Capillary fall, that is H equal to 4 sigma theta rho g into d. The capillary, for mercury, that is angle is 130, that is angle 130 is to give the minus indication. Okay, the calculate the capillary effect in millimeter in glass tube of 4 mm diameter when immersed in water and mercury. From that we can find the capillary rise, that is capillary rise FH equal to sigma value is given, and for water theta is equal to 0, rho value is given. From that we can find the capillary effect of water and capillary effect of mercury. Here also rho 4 into sigma value is 0.51 cos theta, cos 130 is equal to, the value is come in terms of minus. The minus sign indicates that depression, capillary depression. Okay, next, vapor pressure. All the liquids have a tendency to evaporate when exposed to the gaseous atmosphere. The rate of evaporation depends upon the molecular energy of the liquid, which in turn depends upon the types of liquid and its temperature. Vapor molecule exerts a partial pressure above the liquid, that is known as vapor pressure. Okay, that's all.